Welcome to my video lecture series in Object-Oriented Programming. This is Professor Janice Raymond Tan from the College of Computing and Engineering. For this video lecture, we will cover the topics about encapsulation. Throughout this video, we will discuss access modifiers, encapsulation in Java, getters and setters, read-only and write-only class. Access modifiers. The most important principle of object orientation is encapsulation. This is the idea that the data inside the object should only be accessed through a public interface, that is, the object's methods. If you want to use the data stored in an object to perform an action or calculate a derived value, we define a method associated with the object which does this. Then whenever we want to perform this action, we call the method on the object. We consider it bad practice to retrieve the information from inside the object and write separate code to perform the action outside the object. By now, you are quite familiar with the public keyword that appears in almost all our examples. Here, the public keyword is an access modifier, meaning it is used to set the access level the way we can access for classes, attributes, methods, and constructors. There are two types of modifiers in Java, the access modifiers and the non-access modifiers. Types of access modifiers. Classes are packed in a package which can be used as a method for grouping together related classes. Considering the types of access modifiers, we have the private, which is accessible within the class, but not with the entire package where it belongs. Not accessible outside the package by subclass. Subclass will be discussed in the topics about inheritance. And not accessible also outside its own package. We have the default, which is the default access modifier if you did not specify any during class, fields, and method definitions. It is accessible within the class and the entire package where it belongs, but not accessible outside the package by subclass and not accessible also outside its own package. We have the protected, which can be more understood if we are dealing with inheritance. It is accessible within the class, the entire package where it belongs, and even outside the package by subclass, but not accessible outside its own package. We have protected, which can be understood if we are dealing with inheritance. It is also accessible within the class, the entire package where it belongs, and even outside the package or the subclass, but not accessible outside its own package. Types of access modifiers. In this example, we have created two classes, the student and main. Student class contains private fields and private class methods. We are accessing these private members outside the class, so there is a compile time error. So notice that in the given example, we defined the class fields ID and name as private, as well as the display method. Upon creating an object of the student class inside the main of the main class, we try to access and print the name of the student object. Since the name class is defined as private, it will generate a compile time error since once declared as private, it will only be accessible inside its own class where it is defined. Example is a student class. Same happens when we try to access the display method, which is declared as private. So we will encounter a compile time error while accessing private class fields and private methods outside its own class. Default. It is accessible only within the package. If you don't use any modifier, it is treated as default by default. The default modifier is accessible only within the package. It cannot be accessed from outside the package. It provides more accessibility than private, but it is more restrictive than protected and public. In this example, we have created two packages, pack and mypack. we are accessing the student class from outside its package. Since student class is not public, it cannot be accessed from outside the package. Now, to demonstrate to you the use of the default access modifier, we will consider creating a project named pack_demo, and we will define two different packages: pack, which will contain the student.java, and mypack, which will contain the main class. Okay, so the first step is to make our package named pack. Okay, so type the name of your package here, finish. Then inside the pack, which is the package that you created, right click, new, class. So by doing that, you'll be seeing here the name of your package, where your student class or where your class to be defined will be included. So in our case, student.java or student class will be stored inside the package named pack. Okay, so we will not include a main method for this one because we will just define the class fields and methods of the student class. So now, you'll be seeing here. So by defining a class inside a particular package, you'll be seeing the name of the package at the top of the file. Okay, so since we are dealing with the default access modifier, so we will not define the class as public. Again, by defining class or by not defining any access modifier before the class name, class fields, or methods, it means that you are defining them using the default class or the default access modifier. So let us define class fields, which are both, let's say, default access modifier. Okay, so we will define int id and string name. Okay, so again, by defining int id and string name not having access modifier, ibig po sabihin, we define both of them as default. Now let us define student. Okay, so student will be our constructor. Okay, specifically, we will put parameters. That's why this will be called as parameterized constructor, which is also default, not having any access modifier. So we will accept int id and string name as the parameters. So inside this constructor, what we need to do is just to assign the content of your parameter, okay, to its corresponding class field. In our case, we will access this.id. Ibig sabihin, kukunin natin yung class field na id by using the keyword this.id. Then we will pass this one as the value. Okay, same what will happen with the name class field. Okay, so that will be our parameterized constructor. Then we will define also a class method using a default access modifier. Again, by just defining void followed by the name of your method, you are defining or creating a method which is using the default access modifier. So here, we will just be displaying the values of both class fields. Okay, so id, let's put a label here, this.id. Another one for name, so name as a label, and access the value of the class field by using this.name. Okay, so we are done defining our class student inside pack or package pack. So this time we will make another package named mypack. So mypack. So this is where we will define the do you call that main class. So right click, new class. So we will define this as main. it will have the public static void main because this will execute the program. As you notice again, the main method is now inside the mypack because we created the class by clicking the right mouse button at the top of mypack. Okay, so finish. Okay, so this time we are in the mypack. We will define main and we will create a student object. Student, let's say stud is equals to new student. So we will pass ID 123 as integer and a name, let's say John Doe. Okay. So since we are dealing with two different packages, maybe you'll be seeing an error just like this one, which means student is not visible. So this will be not visible inside this class since main class is residing or is stored in the mypack package while student.java is residing inside the pack package. Now, for example, I want to recognize a student class inside main.java. What I need to do is first import this package inside this package. So the way to do that is to type import the name of your package, example pack in our case, then dot asterisk, which means everything inside the package named pack will be imported. So by doing that, still we will not able to access the student class. Okay, so we have still error here, and even by calling the display method, okay, we will also encounter an error. So by running this, you will get this particular error. Again, the reason is just we defined the class as default. That is the reason why it is not accessible inside this package. And that is a quick demo on how to use the default access modifier. The protected access modifier is accessible within package and outside the package, but through inheritance only. Since we have a separate discussion on inheritance, this will be just an overview. The protected access modifier can be applied on the data member, method, and constructor. In our example here, we define the method named display as protected. It can be applied on the class. It provides more accessibility than default modifier. In this example, we have created the two packages again, named pack and mypack. The student class of pack package is public, so can be accessed from outside the package, but display method of this package is declared as protected. So it can be accessed from the outside the class only through inheritance. Now, the way we perform inheritance is to put the extends keyword here, followed by the name of the class to inherit right after the class name of the class who will inherit. In our case, the main method or the main class will inherit the student class. In that case, we use the extends keyword right after the main class, which makes the display method inside the student class accessible inside this class even though they are within the different packages. So in our case again, student is the one who will be inherited by the main class, which means everything inside the student class are now accessible, including the protected fields or methods inside the main class. That is why in this example, we will no longer receive an error. The public access modifier is accessible everywhere. It has the widest scope among all modifiers. In this example, we have created the two packages, pack and mypack. The student class of pack package is public, including its class fields, constructors, and method. So all of them can be accessed from outside the package. That is why we are able to successfully run the sample program since we did not violate any rules in terms of access modifiers. So encapsulation in Java. It is a procedure of casing up of codes and either associated data jointly into one single component. It is like a medicine capsule having different components packed as a single unit. You can construct a completely encapsulated class by making all of its member data within a class as private, which is an access modifier or access specifier. Moreover, you can implement the setter and the getters, which are public methods, in order to set and get data from within a class and not by directly accessing the data of the class by defining them as public. Encapsulation is a way of packaging data and methods together into one unit, and encapsulation gives us the ability to make variables of a class keep hidden from all other classes of that program or namespace. Hence, this concept provides programmers to achieve data hiding. To achieve encapsulation in Java, number 1, declare class variables as private and protected. Protected if inheritance is used. Assign setters and getters a public access specifier method for modifying and viewing values of the variables. We can create a fully encapsulated class in Java by making all the data members of the class private, and now we can use setter and getter methods to set and get the data in it. So what are the advantages of encapsulation in Java? By providing only a setter and getter method, you can make the class read only or write only. In other words, you can skip the getter or setter methods. It provides you the control over the data. Suppose you want to set the value of ID, which should be greater than 100 only, you can write the logic inside the setter method. You can write the logic not to store negative numbers in the setter methods. It is a way to achieve data hiding in Java because other class will not be able to access the data through the private data members. The encapsulated class is easy to test, so it is better for unit testing. The standard IDEs are providing the facility to generate getters and setters, so it is easy and fast to create an encapsulated class in Java. Encapsulation analogy, coffee machine. To further understand what is encapsulation, consider the concept of a coffee machine. From the outside, it has a button, few holes, and a display. This is the perspective of an ordinary user or owner. What do you think will happen if the electronic components are exposed to ordinary users? Of course, everything will be in chaos and possibly the ordinary user can be electrocuted. The secret of reliability and simplicity of a coffee machine, all details are well tuned and hidden inside. The idea of encapsulation comes if we want to control the access of the users to the class fields and methods we created. Same with the coffee machine, we don't want to expose everything to the users. It should only be exposed only to those technicians who can fix the coffee machine. In our case, the technicians are the programmers who fully understands what controls we define in our class. To achieve data hiding to perform encapsulation, you should understand the concept of getters and setters. You learn that private variables can only be accessed within the same class. An outside class has no access to it. However, it is possible to access them if we will provide public get and set methods. So when we say get, we are trying to access the value stored in our private class fields from a separate class outside that class. So when we say set, we are trying to put or assign values to a given class field. In our given example, defining class fields as private, just like private ID and private string name, hides the data from other classes. So here in the main class, if we will try to type, let's say for example, directly stud1.id, it will not be possible since ID is now defined as private. Same with name. So stud.name is not also possible. So if we need to create objects having private class fields, and we need to provide a way to access the private class fields outside its own class, defining public getters and public setters will solve the issue. So now accessing the class fields not using the public getters and public setters is not possible. Now to achieve data hiding and for us to access the value of ID and name inside the main method or inside the main class, we need to define a getter, just like this one, and setter. So here in our example, we defined a get ID and a get name as getter for ID and name. Okay, so take note of the naming convention. Once we say we define getter and setter, we need to provide a get keyword or a get word or a get term before the name of your class field. So we will follow the lower camel case for this one. So which means when we say getter, the only syntax is as simple as defining this as always public, followed by the data type being returned. So the data type here to be returned will depend upon the data type of your class field. So since we defined ID as integer, we will define also the return type as integer. So in defining this as a different data type will not work. Okay, so public int get ID, and the only thing that we'll be doing inside the body of this getter is to return the value of the class field. So return keyword this.id. So when we call get ID inside this class, we will be able to get the value of the ID, okay, through it's a public getter, not using directly ID. Okay, so that's the way how to access the value using getter. So same what will happen for the name. We will define get name. Now what about setter? So let's say for example you want to assign a new value in ID outside this class. Again, by doing stud.id equals 123, it will not work. Again, because ID is now defined as private. So we don't have any direct access to its class fields. So what we need to do is define setter. So on difference between setter and getter, it will return the value. Okay, setter, we will put the value. So the way we create a setter is this syntax, following this syntax. Public, of course, it should be visible outside this class. That's why public. Void, without any return value as always. Set, so kung kanina is get, so this time we will use set ID. So this will be the setter for the ID, and this will accept a parameter. Of course, if we want to change the value of ID, we need to pass value as a parameter of the setter. Notice that setter and getters are just methods. Okay, so public methods po sila. Now, inside the body of setter, you just have to assign this.id equals to the value being passed. Okay, so that will be the way for you to do setting and getting. Now, in our main.java here, okay, let's say for example, we define stud1 as a new student object. And for example, I want to put value or to set a value for the ID of stud1. So as you can see here, the name of your object stud1, this time instead of stud1.id, we use stud1.setID. So this is our setter method for the ID. So passing 1, 2, 3 to the setID method will assign the value of ID to the class field ID. Okay, so if you will type stud1.id directly equals 1, 2, 3, you will generate an error. Okay, so say what happens in set name. We pass John Doe string. It will be assigned to the class field name. Now using get ID, okay, we will be able to get the value of our setters or of our class fields. Okay, so stud1.getID. So you have to add the open and close curly brace after the get ID. I forgot to put that. Okay, so stud1.getID, since this is a method, we should put open and close parentheses right after the get ID. Otherwise, it will not work. Okay, so stud1.getName, again, followed by a pair of open and close parentheses. Then close parentheses for the print line. So you have to change the code for this one. I forget to change. Okay. So by doing so, you will be able to achieve encapsulation and using getters and setters to implement data hiding. Okay. So this will be the syntax for getter methods. Getters are also methods having return values and names. Get as the prefix. Keep in mind that the return type should always match the type of data as defined in the class field. In our case, since the name class field is defined as int, or the ID class field is defined as int, the return type of getID setter should also be of type int. The body of the getter will always contain the return keyword followed by the this keyword and the name of the class field being returned. In our case, return this.id. Our example shows an encapsulated class field since we are able to hide the actual class field from outside by defining it as private, and we use the public access modifier for its getter method to make it visible outside indirectly. Setters, like getters, are also methods. Keep in mind that the setters are always void in return type, which means having no return value, having names set as prefix, and always accepts parameter. Like getters, the parameter type should be the same as the type of the data as defined in the class field. In our case, since id is defined as int, the parameter should always be will always or is considered integer also. The value of the setter should always contain the assignment of the value from the parameter received to the class field. In our case, this.id is equals to id. Naming convention for getters and setter is that they start with either get or set, followed by the name of the variable with the first letter in uppercase for the class field name. Read-only class. In the given example, you cannot change or set the value of the course class field, which is bsit, since there is no setter method defined for the private class field course, which makes it read-only. So the getter method is only defined. So kaya siya naging read-only class. As you can see here, it only contains getter method. Okay? This one. So get course. So that's why it is read only. We will not be able to change the value of the course class field. So by doing so, let's say for example, stud1.set course bscs error, stud1.course bscs compile time error also. Okay? So this is read only class. So what you need what only you can only do is to call the get course to get the value. That's why read only. You will not be able to put values in the course class field. Now write only class. So when we say write only class, it is a Java class which contains setter methods only. Okay? Compared to the previous example, instead of defining the getter, this time we are defining a setter for the course. Okay, in the given example, you cannot get the value of the course class field since there is no getter method defined for the private class field course, which makes it write only. You can only change the value of the course class field. So you will not be able to do this. Stud1.getCourse is the right syntax for calling the getter followed by parentheses. Okay, so this will generate an error because there is no get course or a getter defined in this class. So stud.course also will generate an error because course is now defined as private and course cannot be accessed directly outside this class. Now in summary, we could say that access modifier sets the access level for classes, attributes, methods, and constructors. There are 4 types of Java access modifiers, namely private, default, protected, and public. Encapsulation is a way of packaging data and methods together in one unit, which gives us the ability to make variables of a class keep hidden from all other classes of that program or namespace. By providing a setter or getter method, you can make the class read only or write only. Now for this lesson's activity, create your Java program that will make use of encapsulation in a smartphone class following the possible class fields from the given image. Include a main method of the main class to execute the program. Create a sample smartphone object and provide values using getter or using setter methods of the class fields you identified, and print the values of all class fields in the main method using the getter methods. Post the link of your working Java code using your account in codeva.io inside the post tab of week 6 channel of our MS Teams. So here is the given image. So this will be the basis for identifying the possible class fields and methods, if in case, of a given smartphone. Okay? So that's it for now. Thank you for watching and hope you enjoyed this video. For inquiries, feel free to post your questions in our group chat. In our next video, we will discuss all about class diagram using Unified Modeling Language. Don't forget to visit the links in the references section for more information about this lesson. See you in the next video.